Gomer here with the introductory video for autorisk. In this video I'm going to describe what it is, what the contents are of this project, what the goals of the project are. I'll describe the server in an overview fashion, describing the message types and the game flow. Also any ideas to improve the game going forward. What it is game theory exercise that borrows from the popular board game Risk, where you write player code ultimately to participate in tournaments over the internet. What's provided is a server code which controls the generals and facilitates the game, and sample player code that you would extend if you're writing it in Perl with your logic. The protocol that regulates the communications is part of the definition. Again, the goal is to publish a framework that supports internet play, to publish a message-based protocol, to publish the server code, which is in Perl, to publish sample player code also in Perl that you would extend through subclassing if you do it in Perl. A note on the message-based protocol is to make it never necessary that the player's code be published. Only the behavior of your bot is exposed in tournament mode. And you don't really need to do it in Perl if you can write it in another language that supports the protocol. Here's an overview of tournament mode, where the central component, of course, is the server that controls the game flow. It determines whose turn it is, it rolls the dice, it tracks the state. It writes these state messages out to files for offline reporting. More on that later. There's metadata that's read in that defines the map and any rule variations to the server. Here we see 6 different generals depicted as communicating over the internet, potentially on 6 different machines. Each general needs to have a separate memory image to support the PGP. Also, the server needs a separate memory image to support PGP. The reason for this is that I found that PGP and SOAP don't work well together in the same memory image. SOAP modifies the binary data that PGP is trying to sign or encrypt. So what I did is I separated out PGP into a separate memory image connected by 2 shared memory segments. We need this on the server, and every machine that's supporting a general also needs this separate memory image for PGP. This code is provided. You don't need to code this part of the project. Same information depicted a little differently. Here we see 6 players potentially on 6 different machines, each with an open PGP memory image talking to a SOAP server. The SOAP server is forked off its child processes, which talk with the shared memory segments that control the flow of the game, and also these child server processes have access to an open PGP separate memory image, which I just explained. The server processes also write to the log files, which I explained briefly, and for which I have a separate video describing these 3 components: the logging, the Perl script that's GD based, and the viewing of the PNG files. This is done offline and of course asynchronously. Okay, here in local mode is different. All 6 players would be invoked on the same machine. There's no crypto. The server code is compiled in with the player code, but the server code talking to the shared memory segments is largely the same as in tournament mode. So the big difference is that the state is passed from the server code to the player code only as a reference, not as a serialized JSON image, serialized JSON scalar. So if the player decides that wants to modify the state for whatever reason, the player is responsible for serializing that hash ref into a separate memory image. Here's the same information about the server code writing to log files, yada yada yada. You heard it. Separate video for these 3 components. Message types. The general has a registration message type which starts the game, and other than that only sends turn messages or maneuvers, either a redemption maneuver, a reinforce maneuver, or an attack maneuver. Fortification is a special type of attack maneuver which indicates the end of this particular general's turn. Note here that I didn't implement the canonical protocol where the defender gets to choose how many troops to defend with. Messages from the server to the general. There are 5. 2 of them are special case for the end of the game, victory and defeat. The other 3 are requests for maneuvers, either a redemption maneuver, a reinforce maneuver, or an attack maneuver. Very simple. Here's the game flow. Most of the time, the general is in a block state waiting for a state message. When it gets a state message, it wakes up, determines, because getting a state message indicates it's your turn. It analyzes the state, formulates a maneuver, and sends the maneuver to the server. Once it's done that, it goes back into block state. Conversely, the server, after sending the state maneuver, goes into a block state, waiting for... Let me back that up. The server, after sending a state message, will go into a block state, waiting for a maneuver. When it gets the maneuver, it validates the maneuver, determines the change in state, and sends another state message. So at any time, while the server code is running, all the generals should be in a block state. And while a general is executing code, the other generals should be in block state and the server should be in block state. What's left to do? Lots. Basically determined by what features you want to see. I've thought about internet play and private messages, debug mode, rule variations. These are all nice to haves down the road if there's interest. In closing, I want to express gratitude to Hasbro for the board game and Final Rewind for the PNG viewer that I've been using, and of course to all those who made Perl possible. Also, if I've discussed this game with you and you've tolerated it, I want to thank you too. So, if you're interested in this project, please view my other videos for more detail and express interest. Thanks for watching.